In less than 4 meters of water off the coast of southern Greece, there is a town that should have disappeared completely. Its streets are still there. Its courtyards are still there. The outlines of houses are still visible. Graves still mark the ancient landscape. And beneath the surface, the remains of a settlement that people used thousands of years ago are waiting in a place most modern travelers would simply swim over without realizing what lies below. This is Pavlopetri, a prehistoric coastal settlement off the Laconian coast opposite the island of Elafonisos, and archaeologists regard it as the oldest known submerged town in the world. But the strangest part is not that it ended up underwater. It is what the underwater map revealed when researchers finally returned with modern technology more than 40 years after the first survey. Instead of scattered ruins, they found an organized settlement with streets, buildings, open spaces, burial areas, and evidence of connections extending across the Aegean. And the deeper researchers went into the evidence, the more the question changed. This was not simply a lost town. It was a record of how Bronze Age people built, traded, buried their dead, adapted to a changing coastline, and eventually watched their familiar world disappear beneath the sea. The story begins not with a legendary king or a treasure hunter, but with an oceanographer looking through the water. In 1967, Nicholas Fleming of the Institute of Oceanography at the University of Southampton identified submerged ruins off southeastern Laconia in the Bay of Vatica. The site lay in shallow water, just 1 to 4 meters deep in places, which made the remains unusually accessible compared with many underwater archaeological sites. A year later, in 1968, a team from the University of Cambridge spent 6 weeks surveying the ruins using a fixed grid system and hand tapes. They produced a plan showing what appeared to be a prehistoric town covering roughly 300 meters by 150 meters. The initial interpretation connected the settlement with the Mycenaean world, although later research would reveal that its history was actually much longer. At that moment, however, the central mystery was obvious. Why was an entire settlement sitting below the sea? And how old was it really? For almost 4 decades, Pavlopetri remained remarkably understudied. The ruins had been mapped, but the 1968 survey could not provide the kind of detailed 3-dimensional record that modern underwater archaeologists would later consider essential. In 2007, archaeologist Chrysanthi Gallo at the University of Nottingham began reassessing the earlier discoveries. She worked with John Henderson and other researchers to develop a new project that would return to the site using modern methods. When Henderson, Gallo, and Nicholas Fleming visited the ruins again in 2008, the original outlines were still visible on the seabed. They could see walls, streets, and rock-cut tombs, but they also noticed that some graves had been disturbed or damaged. More importantly, the seabed itself was changing. Sand moved across the ruins. Waves and currents could slowly erode exposed surfaces. Boat activity posed another risk. If researchers wanted the site preserved, they needed to document it before the sea changed it further. Then came 2009, and the site finally entered a new era. A joint Greek and British team, working with the Hellenic Ministry of Culture and the University of Nottingham under a British School of Archaeology at Athens Permit, began a major underwater archaeological project. The objective was not simply to take photographs. The researchers wanted to establish when the settlement was occupied, what it was used for, how it developed through time, and how the local landscape eventually became submerged. During the first season, archaeologists worked for more than 2 weeks recording the visible remains with modern digital technology. Total stations were used from shore, while sector scan sonar helped map structures underwater. The team did something that transformed their understanding of Pavlopetri. They found that the settlement was substantially larger than the 1968 survey had suggested. More than 9,000 square meters of previously unknown buildings were identified, including a large rectangular hall and a new street lined with structures. The discovery is the moment the story stops looking like a group of ruined foundations and starts looking like a town. Imagine descending into clear, shallow water and seeing walls arranged not randomly but according to a plan. You are not looking at one collapsed house. You are looking at the streets. You can follow a route where people once walked. You can identify places where houses stood beside passageways. You can find courtyards where daily activity may once have unfolded. And somewhere beyond those residential areas are graves, stone-lined burials, and other evidence that the inhabitants had created a settled community with a relationship between living space and funerary space. It is one thing to know that people lived along the ancient Greek coast thousands of years ago. It is something completely different to see the physical layout of their neighborhood still visible beneath the water. The dating made the discovery even more significant. The 2009 survey recovered ceramics, confirming Mycenaean occupation, but the material also suggested occupation throughout much of the Bronze Age, from at least around 3000 BC to about 1100 BC. Researchers even recovered final Neolithic pottery, indicating human activity in the area possibly reaching back into the mid-4th millennium BC. That means Pavlopetri was not simply a Mycenaean settlement that existed for a short period before being swallowed by the sea. Its history extended across thousands of years of changing Aegean societies. The University of Nottingham's project describes the settlement as having a long sequence that reaches from the final Neolithic through the Bronze Age and into later periods of activity. Different generations came, rebuilt, adapted, traded, buried their dead, and changed the settlement over time. This is also where the Atlantis comparison needs to be handled carefully. Plato's Atlantis is a literary story first recorded in classical Greece, and dialogues written in the 4th century BC. Pavlopetri's earliest archaeological activity dates thousands of years earlier. So, when people say the submerged town is older than Atlantis, what they really mean is that the settlement existed long before Plato wrote about Atlantis. That does not prove Pavlopetri inspired Atlantis, and archaeologists do not have evidence establishing that connection. The comparison is nevertheless useful because both stories involve a landscape associated with the sea and the idea of a place disappearing from human memory. The difference is that Pavlopetri is real archaeology. We can map its streets, recover its pottery, study its graves, reconstruct its shoreline, and investigate the physical processes that placed the settlement below the modern sea surface. Atlantis belongs to literature. Pavlopetri belongs to the archaeological record. One of the most astonishing parts of Pavlopetri is how shallow it is. In some areas, divers can reach the archaeological remains only a few meters below the modern surface. That means the ancient settlement is not hidden in the abyss. It is almost within reach of an ordinary swimmer, but shallow water can be deceptive. Sunlight reaches the seabed, waves move sand, anchors can damage walls, and biological growth can hide archaeological features. What seems like a protected underwater time capsule is actually a fragile environment. Researchers therefore had to balance exploration with preservation. The objective was not to strip the site open, it was to record as much as possible while minimizing disturbance. The technology used in 2009 changed what underwater archaeology could achieve. The team combined traditional archaeological observation with modern digital survey methods. Sonar created images of structures that divers could then examine. Total stations linked underwater measurements to precise geographic coordinates. Photogrammetry and robotics later allowed the team to produce a three-dimensional digital model of the site. An autonomous underwater vehicle was deployed to capture stereo imagery, producing a photorealistic record that could be stitched together into a larger model. Suddenly, archaeologists were no longer looking at isolated walls. They could study the town as a three-dimensional landscape. This is a fundamental change in archaeological interpretation. A wall has meaning when you know what it connects to. A room becomes more understandable when you know whether it opens onto a courtyard or a street. A tomb means more when you can place it within the settlement. And the layout raised a bigger question. What kind of town was this? It was not enormous by modern standards, but for the Bronze Age, its organization was significant. The streets indicate planning. The buildings were not simply scattered along the shoreline. Different structures occupied defined spaces. There were domestic areas, larger buildings, open areas, and burial zones. Such organization implies rules. It implies property boundaries, shared routes, construction traditions, and some level of community planning. The settlement was not simply a temporary camp where people stayed during favorable weather. The archaeological pattern indicates a permanent or repeatedly occupied community that invested in architecture and infrastructure. That is important because coastal settlements are often underestimated. A modern viewer might imagine Bronze Age communities as small villages of farmers living far from any complex trade network. Pavlopetri challenges that image. The site was ideally positioned near important sea routes. Its location in southern Laconia placed it near the maritime networks connecting the Greek mainland, Crete, the Aegean islands, and wider Mediterranean trading systems. The excavated material reinforces that picture. During the Neopalatial period, around 1700 to 1425 BC, archaeological deposits indicate close trading connections with the palaces of Minoan Crete. That makes Pavlopetri more than a local village. It appears to have participated in a much larger maritime economy. This changes the way we imagine the people who lived there. They were not isolated villagers waiting for history to arrive. They lived within a network. Goods moved, pottery moved, ideas moved, people moved. A coastal town could serve as a point where different worlds met. A ship might arrive carrying objects from another island. Traders could exchange materials. Sailors could bring unfamiliar styles. Local craftspeople could imitate foreign designs or develop new ones. The evidence from Pavlopetri suggests that its people were connected to the wider Aegean world, and the location itself helps explain why. The sea was not a barrier, it was a highway. The sea, however, was also the force that eventually changed the town's fate. And this is where the real scientific mystery becomes much more interesting than a simple story about a sudden tsunami. Pavlopetri did not necessarily sink in one dramatic event. Research into the site's geomorphology indicates a much more complicated process involving changes in relative sea level and tectonic movement. The southeastern Peloponnese is part of a highly active tectonic region associated with the convergence of the African and Eurasian plates and the tectonics of the Hellenic arc. The coastline has experienced uplift and subsidence over geological and historical time. Researchers have therefore investigated former shorelines, submerged beach rock bands, and changes in relative sea level to reconstruct how the settlement gradually became submerged. Recent research makes that story even more detailed. A 2024 study examining late Holocene sea transgression in Vatica Bay reconstructed former shoreline positions using submerged beach rock generations, marine terraces, and tidal features. The research suggested that when relative sea level was around 5 meters below present levels, Elafonisos was connected to the mainland by an isthmus. During the late Bronze Age, the relative sea level had risen but did not necessarily destroy the town itself. Later transgression between roughly 1190 and 700 BC caused further flooding of the isthmus and altered the coastal environment. In other words, the landscape was changing gradually. Pavlopetri did not simply fall into a hole in the earth one morning. The shoreline itself was moving relative to the settlement, and eventually the sea reached places where people had once lived and walked. This matters because it changes the human story. Imagine living in Pavlopetri while the coast slowly changes. The sea begins closer to your buildings than your grandparents remember. A path that once connected the settlement to another area becomes wet more frequently. Storms damage parts of the coast. Salt water reaches places where it once did not. A cemetery near the shoreline becomes increasingly vulnerable. People respond. They repair structures. They abandon others. They adapt. Eventually, some areas may no longer be worth maintaining. The settlement's relationship with the sea changes before the archaeology ever becomes a submerged monument. What looks to us like a sudden lost city may have been the result of generations of gradual environmental change. This is one reason Pavlopetri is so valuable for understanding ancient climate and sea level change. Archaeological settlements are fixed points in time. Buildings were constructed at particular elevations. Roads were designed for particular landscapes. Cemeteries were placed relative to shorelines and hills. When those structures are later found underwater, they become clues about past environmental conditions. Scientists can compare their elevations with radiocarbon dating, beach rock formation, sediment deposits, and regional sea level models. Archaeology therefore becomes a tool for environmental reconstruction. The people of Pavlopetri unknowingly marked the coastline for future scientists. The burial evidence also tells us something about social organization. Researchers identified stone-lined graves, chamber tombs, and other funerary features. A cemetery is not simply a collection of bodies. It represents a community's relationship with ancestry and memory. Choosing where to bury the dead, how to construct a grave, what objects to include, and how the cemetery relates to the settlement all reflect cultural decisions. Pavlopetri's funerary evidence therefore tells us that the people who lived there cared not only about immediate survival, but about maintaining relationships with the dead. Their town had places for houses and places for burial. The landscape had social meaning. And that is one of the most haunting details about an underwater town. The streets are empty, but they were not abandoned because everyone vanished instantly. People lived there long enough to create habits. They knew which path led to a courtyard. They knew which house belonged to which family. They recognized boats arriving from the horizon. They knew where relatives were buried. Children would have grown up with the shoreline as part of their daily environment. For them, the town was not an archaeological site. It was home. The fact that we now describe their streets with words like structures and architectural remains can hide the human reality. Every wall represents a decision someone made. The 2011 excavation strengthened that human picture. Archaeologists identified in situ deposits associated with structures and dated material from the Neopalatial period. The evidence indicated connections with the palaces of Minoan Crete and suggested that Pavlopetri functioned as a Bronze Age trading center. The same excavation program also used an autonomous underwater vehicle and stereophotogrammetry to create a detailed three-dimensional record of the site. Meanwhile, scientists investigated old shoreline features and beach rock bands to help reconstruct the sequence of submergence. The project was therefore interdisciplinary from the beginning. Archaeology, oceanography, geomorphology, robotics, photogrammetry, and marine science were working together. The more researchers mapped, the more the city-like character became obvious. A settlement of this kind requires more than houses. It requires circulation. Streets are social infrastructure. They determine how people move, how goods are transported, how neighbors interact, and how the community handles access. Courtyards create shared spaces. Large buildings suggest communal, administrative, or specialized functions. Burial zones establish a relationship between the living settlement and the dead. The town structure therefore provides a glimpse into social organization even when no written documents survive, telling us who governed the place. And then there is the question of preservation. Why does so much remain? Part of the answer is that the shallow seabed preserved walls and layouts in place. Buildings collapsed, but their stone foundations remained. Sediment moved across the surface without completely destroying the underlying plan. The water environment also restricted some later development that might have erased the settlement on land. But underwater does not mean safe. The site is exposed to waves, currents, sediment transport, biological processes, boat traffic, anchors, pollution, and human disturbance. The World Monuments Fund placed Pavlopetri on its 2016 World Monuments Watch because of these threats. It specifically identified pollution, damage from boats anchoring, looting, and infrastructure construction as risks to the underwater heritage, and that danger has become even clearer in the newest work. In July 2026, John Henderson and Nicholas Fleming published a peer-reviewed study in the International Journal of Nautical Archaeology focused specifically on preserving Pavlopetri. Their research examined natural and human threats, including sediment movement, wave action, storm surges, dredging, and boat traffic. The study argues that the site's future depends not only on archaeology, but on understanding the coastal environment that continues to act on the ruins. This is important because Pavlopetris is not a frozen time capsule. It is an active archaeological landscape. The same forces that submerged the town are still moving sediment around it today. That creates an uncomfortable irony. The sea preserved Pavlopetri long enough for archaeologists to discover it, but the same sea can eventually destroy it. Every wave carries energy. Every storm shifts sediment. Every anchor can break stone. Every biological film can alter a surface. Every human visit has a possible cost. The site's survival therefore depends on recording it digitally while protecting the physical remains. This is why the 3D models matter so much. If the original stones eventually erode, researchers will still possess an accurate digital record of their arrangement. Preservation today is increasingly about both the physical site and the information contained within it. There is another question that refuses to disappear. Why was Pavlopetri abandoned? The archaeological evidence does not support one simple dramatic answer. The settlement appears to have a long history, with changes through this Bronze Age. It may have experienced environmental stress, shifting trade patterns, and changing regional political conditions. Eventually, coastal transformation made its relationship with the sea increasingly difficult. Some research suggests the settlement was already experiencing flooding or environmental change by later periods, but archaeology rarely provides a single dramatic moment explaining every abandonment. A town can decline gradually, families leave, trade routes shift. Buildings are not repaired, new centers become more attractive. Environmental change increases the cost of staying. In the end, a town may disappear without a single catastrophe. That is why Pavlopetri should not be forced into the Atlantis story. Atlantis is a story about a powerful civilization destroyed dramatically and suddenly. Pavlopetri represents something more realistic and therefore more useful. A real settlement can disappear because the environment changes over generations. People do not necessarily wake up one morning to a giant wave. Sometimes the sea advances slowly. Sometimes earthquakes alter the land. Sometimes economic networks change. Sometimes communities move. Sometimes several pressures combine. The archaeological record rarely gives us one villain, it gives us a process. The research also shows that the earliest phases of Pavlopetri may be older than its famous Mycenaean identity. Final Neolithic pottery indicates activity dating much earlier than the classic Bronze Age town. A 2022 oceanographic synthesis described occupation extending as early as around 3500 BC, while the University of Nottingham's own survey recovered evidence suggesting activity from at least the mid-4th millennium BC and continuous Bronze Age phases. The difference between those dates matters because archaeology often works with probabilities and evidence thresholds. One pottery fragment does not mean a fully developed town existed at exactly the same date. The careful conclusion is that human activity in the area predates the later Mycenaean settlement, while the organized town visible underwater developed through subsequent periods. The town's apparent age also makes it important for understanding early urban development in the Aegean. We often associate ancient cities with monumental structures, giant walls, palaces, and temples. Pavlopetri is different. Much of what survives is domestic and practical. Houses, streets, courtyards, graves. These are exactly the features that allow archaeologists to understand how ordinary life was organized. A palace tells you about elites. A neighborhood tells you how society functioned at ground level. Pavlopetri therefore provides an unusually valuable view of prehistoric community organization. The connection with Minoan Crete is another clue. During the Bronze Age, the Aegean was not a collection of isolated islands. Maritime trade linked different political and economic centers. Crete, the Greek mainland, the Cyclades, Cyprus, Anatolia, and other regions interacted through exchange networks. Pavlopetri's location on the southern Peloponnesian coast placed it close to these routes. Archaeological materials found at the site indicate participation in this wider world. The people living in Pavlopetri could therefore see things entering their settlement that came from places far beyond their immediate coastline. Their world was connected long before modern globalization. And perhaps that is the greatest surprise of all. The town under the water looks ancient because it is ancient. But its organization reminds us that the people who lived thousands of years ago were not living in a world without networks. They were moving through landscapes, creating settlements, trading across water, organizing neighborhoods, burying their dead, and adapting to environmental change. The technology was different. The political systems were different. The scale was different, but the basic human problems were recognizable. Where do we build? Where do we bury our dead? How do we move goods? Who uses this street? How do we protect our homes? What happens when the coastline changes? When should we leave? Pavlopetri does not answer those questions in words. It answers them in stone, and the stone is still there. For decades, however, the world could see only part of the picture. The 1968 survey gave archaeologists a remarkable first map, but modern technology opened the site in an entirely different way. The 2009 project added thousands of square meters of newly identified structures. Later work created a three-dimensional digital model. Excavations recovered material that revealed trade connections and chronology. Oceanographic research reconstructed shoreline changes. Recent conservation research is now examining the threats that could erase the very evidence that made the site famous. Each stage has added another layer, and that leaves us with a strange final image. The oldest known submerged town in the world is not hidden in deep water. It is sitting almost at the surface, a few meters beneath waves, in clear enough water that divers can swim above streets built thousands of years ago. A person on the shore can look across the bay and see nothing unusual. But beneath that water is a settlement that once depended on the exact environment now hiding it. The people of Pavlopetri built near the sea because the sea connected them to the wider world. The same sea eventually covered their streets. It did not erase them completely. It preserved them. And now the challenge is preserving what remains. Because every year the waves continue moving. Every storm can shift sediment. Every boat can become a threat. Every damaged stone represents a piece of information that can never be recovered in exactly the same form. The latest research makes that clear. Pavlopetri is not simply a discovery from the past. It is an archaeological site still being changed in the present. So when you hear the phrase, the world's oldest submerged city, do not picture Atlantis. Picture something quieter. A child walking through a Bronze Age street. A trader carrying goods toward a boat. A family gathering in a courtyard. A worker repairing a wall. A relative visiting a grave. A ship approaching from the Aegean. A shoreline slowly changing. A town gradually becomes more difficult to inhabit. Then picture the final image. The buildings are still standing. The streets are still there. But the people are gone. The water has risen around the stones. The town becomes part of the seabed. Centuries become millennia. Civilizations rise and fall. The name Pavlopetri becomes forgotten. Then, in the 20th century, an oceanographer looks down and realizes that the seafloor is not empty. He sees a town. Almost 40 years later, archaeologists return with sonar, digital mapping, robotics, and three-dimensional imaging. And suddenly, the people who disappeared thousands of years ago become visible again. Not because they left behind a legend, because they left behind a street. That is why Pavlopetri may be more important than Atlantis ever was. Atlantis gives us a story about a civilization that disappeared. Pavlopetri gives us evidence of one. And the evidence is still under the waves.